Hi, Italia. I hope this helps. I always tell my students, remember the power of pause, stop, and rewind. So I'm not going to give a lot of wait time for you to think. So if you need to think something through, just pause the video, because otherwise it makes the video too long and it's boring. All right. On problem 18, the idea of this problem, the main strategy, is that we're going to find the area of this entire sector, and then we are going to subtract off the area of the triangle. So we're going to subtract off the area of the triangle from the area of the whole sector. Now, the area of the whole sector is the part that I think you understand well. I'm going to use 90 degrees, which we see right here is my central angle. Okay, and that is going to be the angle that I'm going to use. So I have 90 over 360 equals pi times 8, which is my radius, squared over 1. You are reducing 90 over 360 reduces to 1/4. 8 squared is 64. Then when I multiply the tops across, I get 64 pi. 4 times 1 is 4. And when I take 64 divided by 4, I get 16 pi. So what 16 pi represents is the area of this entire sector. What I have to do next is subtract off the area of the triangle. Well, the area of the triangle is 1/2 base times height. And because this is a right triangle, this is my base, which is 8. And this is my height, and that is also 8 because it is a radius. So my base and height in this right triangle are both 8 and 8. So I'm going to take 1/2 of 8 times 8, which is 1/2 of 64, which is 32. And so when I take the area of this sector, which is 16 pi, and subtract off the 32, this would be my final answer in terms of pi. For problem number 22, my strategy is going to be different. Because I am trying to find the entire shaded region, I am going to break this up into the area of this sector. Okay, so I am going to find this area right here. Okay, all right, then I am going to add the area of this triangle. So that is my main strategy, is to find the area of the big sector, and I'm going to add the area of the triangle. All right, let's see how much of this is going to erase. All right, here we go. Okay, so for the area of the sector, since this is a 90-degree angle right here, all right, that means that this big angle from here to here is going to be 360 minus 90, otherwise known as 270. Okay, so let me just back this up over here. All right, so I'm going to get the 270 over 360 is equal to pi times 18 squared, because that's my radius. 270 over 360 reduces to 3/4. 18 squared is 324. Then when I multiply the tops across, and then I multiply the bottoms across, I get the 972 pi over 4, which reduces to the 243 number. Okay. Now for the area of the triangle. And on this problem, the area of the triangle is not bad because you have a right triangle. So this means that my base of this triangle is 18 and the height of this triangle is 18, because those are the two segments that make up the 90-degree angle. So when I do my area is equal to 1/2 base times height, I have 1/2 of 18 times 18. 18 times 18 is 324. Half of that is 162. So my final answer is I'm going to take the area of the sector, which is 243, plus the area of the triangle to get my final answer in terms of pi. 23 is harder. The idea of what we're doing is the exact same as the previous problem. We are going to go ahead and we are going to take the area of this sector. So I'm going to be looking at the big sector. So I'm looking at this major Mongo piece. If this was a piece of pie, you would be really hungry. Okay. And then I'm going to add the area of the triangle. Okay. So I'm going to add this. The reason this problem is harder is finding the area of that triangle is going to be harder. We're going to have to use special right triangles. So in keeping with how I've done the previous problems, all right, let's just do the area of the sector. If this angle right here is 120, then I have to take 360 and I have to subtract 120 in order to get this angle. Okay, so that angle is 240. So I have 240 over 360 is equal to pi times the diameter 9 squared. 240 over 360 reduces to 2/3. 9 squared is 81 pi. When you multiply the tops together, you get 162 pi. The bottoms together is 3. And that reduces 162 over 3 reduces to 54 pi. Now, here's where the area of the circle gets tricky. All right. In order for me to find the area of the triangle, I need 1/2 base times height. And you need to remember that a base and a height need to make a perpendicular angle. So what I'm going to do in this triangle is I'm going to cut this in half. If this was a 120-degree angle, then that means this is 60. That would mean here's my 90-degree angle. So this is going to be my base, and this is going to be my height. At the same time, you have a 30, 60, 90 triangle going on. 9 is the hypotenuse. I take half of it, which is 4.5, and that is going to be the short side. And then opposite the long side is going to be 4.5 root 3. And that are my special right triangle rules. So again, my base is going to be 4.5 root 3. My height is 4.5. And I'm going to chuck those into my area formula. So my area is equal to 1/2. Sorry, this is kind of sloppy. I have to write using the pad on a laptop. 1/2 times 4.5 times 4.5 root 3. What I did in my next step, remember the power of pause. I took 1 times 4.5 times 4.5 to get 20.25, and I tacked on my root 3. And then 2 times 1 times 1 gives me 2. Okay, now that is just the area of this triangle. If I need to find the area of this whole region, I have to double that. So that's what I did here. I'm doubling it. And as I'm doubling it, 2 times 20.25 is 40.5. 40.5 divided by the 2 gives me 20.25 root 3 over 3. So I know this looks like a heaping mess and it's awkward, but my final answer here is come on. This is so much easier on a smartboard, sister. Okay, so this is my final answer right here. My final answer is 54 pi plus 20.25 root 3 over 3. And last but not least, and if I made a miscalculation, I'm sorry, it's getting late, but you'll get the idea, but hopefully my calculations are correct. It is the same idea. We are going to, in keeping, we are going to find the area of the big sector. So I'm going to be talking about this area. I'm really, really hungry. Okay, so I'm talking about this area right here. Okay, and then I'm going to tack on the area of this triangle. This triangle is an equilateral triangle. It's 60, 60, 60. Okay. All right, so if this is 60 degrees, in order to find my angle, I have to take 360 and subtract 60 degrees in order to find that big angle from here to here. So the area of my sector is going to be 300 degrees over 360, and that reduces to 5/6. My radius is 12 squared, so that gives me 144 pi. Then when I multiply the numerators, 5 times 144 pi is 720. 6 times 1 is 6. And then when I take 720 pi divided by 6, I get 120 pi. Here's the hard part. The hard part is figuring out the area of this triangle. And just like we've done before, the area of a triangle is 1/2 base times height. But again, I can't repeat enough that your base and your height have to be a perpendicular distance. So in this triangle, I am going to make a perpendicular, and this was a 60-degree angle I just bisected. So that means this angle is 30. This angle is your right angle, and this is 60. So that makes this my base, which I'm going to do a capital B, and that's going to make this my height. But it's a 30, 60, 90 triangle where 12 is your hypotenuse. So if I take half of that, this is 6, and then I take 6 and I multiply it by √3 to get the side opposite the 60 degrees. So the 6 and the 6 root of 3 get plopped in the area formula. Okay. Then I'm going to multiply 1 times, let's get the highlighter. 1 times 6 times 6, which gives me 36 √3 all over 2. 36 divided by 2 is 18. But keep in mind, that is just the area of this region. I have to double it to get the entire triangle. So when I double it, 2 times the 18 gives me the 36 √3. And when I add them together, I get a final answer of 120 pi. Oh, and that should be a plus 36 √3. I hope that helps. If you have any other questions, never hesitate to take a picture, send it to me. Really, I got this all done in about 20 minutes. So have a good evening. Keep the faith. Hang in there.